Welcome. Today in this session we are continuing with the chase of Goldbach theorem proof. Today our chase is going to be of step 2. The step 1 we are seeing is availing the property E is equal to 2m. It is parallel to 4 is equal to 2 plus 2. We had organized single limb organization into a pair of limbs organization. Further, we had availed the middle for its repeated presence in the first limb as well as in the second limb. With it, we have been successful to construct duplexes. In the illustrative situation of E is equal to 66, we have reached that set D1 of duplexes with E66 leading to its cardinality as 34. Otherwise, in general, cardinality is m plus 1. This construction of the set D1 as such becomes the basic construction. Now we want to reach at set 2 and sequentially from D1, D2, D3, and we will continue up till DPI by taking that E with its organization as under root E multiplied by under root E parallel to the organization of 4 is equal to 2 multiplied by 2. We may have a pause here and see that in step 1 we availed the feature 2 plus 2, and further we have also simultaneously availed the feature minus 2 into minus 2 as we had split the single limb organization of E into a pair of limbs organization. And it is this way, though we had constructed D1 a set of duplexes of cardinality m plus 1. However, this format of step 1 as it is of pair of orientations. As in the first limb, we are sequentially progressing from 0 to m by the rule of one more than before, ekadhikain purvain, and by upsutra anurupain, proportionate similarity rule, we have in the reverse orientation have also reached from 2m to m. So this organization, linear organization of a single limb which separates the both endpoints with middle, this organization is availed structuring in such a way that the second half is brought with the second end towards the side of the first end itself, and thereby we have achieved an organization of a pair of limbs of opposite orientation. This feature of opposite orientation and this addition now will help us see how this supplet of 4 is equal to 2 plus 2 will lead us to the general format of E is equal to under root into under root E. This feature is to be availed by taking that if number n is, say, splitting into S cross T, and also if it is accepting split as U cross V, and if S is greater than equal to U, then T will be less than equal to V. It is this feature which in fact will help us see that the split for E for its prime factors to rule out the composites, it will be sufficient if we can rule out the composites of prime factors only up till E. Still further, we can see that when we begin with a 0 with the rule one more than previous one, then in fact we progress only towards one half as the other half remains uncovered. And here for this organization as well, see that we have availed only half of it, as from middle we had a bend. Therefore, as such, the setup as it is of progression from 0 towards one side, say towards plus infinity, and the second half remains uncovered, and out of this half, one half as well, we are availing only a quarter of it, as we are having under the construction a bend here. Therefore, of the total range from minus infinity to infinity with 0 at the middle, we are availing the organization of only middle of the value E, and this coverage from 0 to M as it is remains simply of the 1/4 part. So 1/4 part only is being covered. We can recapitulate that when we are working with the linear organization, then this organization of one space in the role of dimension leads us to 3 spaces as a domain. Further, we can recapitulate that we have seen that the cube as the representative regular body of 3 space permits a split in terms of a 3-dimensional frame of triple spatial dimensions. So triple spatial dimensions are sufficient to reach at the split for a 3-dimensional frame, and this split at a 3-dimensional frame with 2 raised to power 3 is equal to 8 as such is giving a split that at the origin of a 3 space, which is a seat of a 4 space, the coverage for the boundary part of the 8 structural components of 4 space remains worked out exhaustively covered in terms of 2 raised to power 3 as 8 solid boundary components. But the domain, which is a spatial order space, quadruple dimensions are required, so the 4th dimension as such remains unattainable. This unattainability is to be attained now. For the proof of a Goldbach theorem, the step 2 as such is availing this feature that E is equal to under root E into under root E, and the 4 space we know is having a property 2 plus 2, and same also is leading us to 2 cross 2. It is this addition and multiplication operation superimposition which is the inherent feature of the 4 space, a spatial order space. This as such is availed But now in step 2 we are availing this particular feature, and this feature will help us appreciate that when to write 2 is equal to 1 plus 1, taking it to be 1 is not to be split, it is not to be taken as a prime. So we say that we are organizing the numbers now in such a way that we can have the split in terms of this particular step. So we are now today being face to face with the step 2. Now the step 2 is to be reached at, and for it, see that we have to recapitulate first that as step 1 we have constructed duplexes. For this duplexes we have as organization as a single limb range for 0 to E is reached at by construction as a pair of limbs, and then there is a construction of the duplexes. Now these duplexes as these are will help us appreciate that we are having, say, the duplex, say we are having with the upper member dr and the lower member 2m minus r, and the summation value of this pair of elements of this duplex is equal to 2m. Therefore, to prove this conjecture, we have to have scanning for these duplexes, and we have to reach at one such duplex where the upper part and the lower part is of primes. So such a duplex where the dr as well as d2m minus r both are primes. Such a duplex is defined as a prime duplex. So we have to show, we have to reach at, we have to prove that out of the set D1 of duplexes of E in the illustrative case of 66, there exists at least one such duplex which is a prime duplex. So this conjecture, this statement of the conjecture leads us to the exercise for a choice to reach at one duplex of the set D1 which is a prime duplex. Now as a step 2, the reach mechanism technique is going to be that if there is a number, say E, then it would be taken as if it is a product of the primes. Now these primes we know if lead us to, say, E as a number value n equal to, say, split s into t, and if this also gives us u into v, and if s is greater than u, then t must be less than equal to v. It is this feature, it is this value, it is this organization which will help us appreciate that to reach at the primes up till E, it will be sufficient to reach at primes under root E, as E is equal to under root E into under root E will help us that if there is a prime up till E, then the lesser will be the choice for the second, because we know that any number with the split s cross t if we have a choice up till S, then choice for T is automatically available to us. Therefore, this being the situation, and E is equal to under root E into under root E will help us that if we can rule out the primes up till under root E, then the rest split will follow of its own. Therefore, we have to work out the primes up till under root E, and with the help of the primes up till under root E, we can rule out the composites for the entire range of E in this set of duplexes. In this set of duplexes, now we shall begin sequentially with the primes. Say the first prime is available to us is 2. So this range of E 0 to M and then 2M to M leading us to these duplexes. Now we can rule out the values 0 to M, say in the illustrative case 66, value 33. We have to rule out the numbers which accept 2 as a factor, accept the 2 itself as 2 is a prime. Therefore, all the even numbers other than 2 will get ruled out with the help of 2 as a factor, and from the lower limb as well, all the even numbers as well, all the even numbers of this range as well get ruled out. The set D2 be taken as a set which is of duplexes of which the upper member as well as the lower member is not accepting 2 as a factor, except the 2 itself. Now, this way, out of this range of D1, when we will rule out, when we will strike out all the duplexes which are having 2 as a factor for dr or for 2m dr minus 1, the remaining duplexes will be the prime duplexes qua prime 2. This will help us reach from the set D1 of duplexes. Out of these duplexes, we will be having a set D2 as a subset of D1 such that the duplexes which are having 2 as a factor for values 0 to m or 2 as a factor for the range 2m to m, those duplexes will be taken as D2. So the member of D2 is a duplex of D1, element of D1, such that the dr or d2m minus r is not having 2 as a factor. So D2 is going to be the set of prime duplexes reference to 2. D2 is going to be a part of subset of D1. Like that, sequentially, we can from D1 as we are reaching at D2. So from D2 we can reach at D3, means all those duplexes of D2 such that dr and d2m minus r is not having 3 as a factor. Like that, we can have a reach at the chain of subsets, and it is this chain of subsets which can be extended up till dp, where p is the biggest prime factor of under root e range. We can sit comfortably and take that step 2 is the step which is for construction of chain of subsets of the set D1 of duplexes of value E. As step 1, we have constructed a set D1 of duplexes. Now, out of this set D1 of duplexes constructed as step 1, now in step 2, our exercise is going to be to reach at the chain of subsets of set D1. D1 is the set of duplexes. Out of this set of duplexes, we have to reach at the set of the chain of duplexes such that the subsequent sets, say D2 as a subset of D1, is such that its members are prime, qua, prime 2. Then the set D3 as subset of set D2 is a set of duplexes such that the members of D3 are primes, qua, prime 3. Like that, we can sequentially reach up till the subset dp, where p is the biggest prime factor of value under root e. Now this exercise as such is a very simple exercise of elementary steps. Now let us see what are the implications, what are the values, what are the inherent characteristics of this exercise and this construction of the chain of subsets of duplexes. Now for it, let us appreciate that if we are having, say, a circle as a domain, then if we want to find out the division into two parts, so if we are having half part and the half part, now if we want to rule out the multiples of 2, then we can rule out the maximum half part of it and the remaining half will remain. Means if we are starting 0, 1, 2, 3, 4, 5, 6, 7. So the alternative numbers can be ruled out being having 2 as a factor. Therefore, the maximum what can be ruled out is only the half of the range. So of the range, we can rule out only the half range by as the composites of value 2. So numbers accepting 2 as a factor would amount to division by 2. It would mean that we are writing a table of 2, or in other ways we are reaching at the divisions which will be leading us to remainders 0 and 1. So this pair of ranges of remainders 0 and remainder 1 would be there. So remainder 0 is the remainder which is having the set of numbers which are divided by 2, and remaining remainder 1 is that portion which is not divided by 2 or which are accepting 1 as a remainder. Therefore, when we will reach at the duplexes in reference to 2, means when we are reaching at the duplexes prime, qua, prime 2, then out of D1 we are ruling out the half portion, and remaining half portion will remain for us for the further checkup. Now if the remaining portion, this half portion of remainder 1, if it is to be checked further as to how, when we are reaching at D3 as a subset of D2 as duplexes such that its members are prime, qua prime 3, means neither this is divisible by 3 nor this is divisible by 3. It would amount to that when out of the original domain we had ruled out of remainder 0 qua prime 2 divisor 2, and we had left with remainders 1, so it was only value half of the domain. Out of this half of the domain, now when we are ruling out 3, that means we will be again having triple remainders 0, 1 and 2, but this 0 remainder portion will get ruled out and we will have the remaining 1 and 2 remainders to be available. It would amount to, this will be as such put into 3 parts, and 1 part of 0 remainder will get ruled out, and then this of 1 and 2 remainders will remain. It means that initially when we are reaching from D1 to D2, then we are left with only the half portion. When we reach from D2 to D3, then we are again having 2/3 portion remaining, as 1/3 portion stands ruled out. So as a combined effect, we will be having only this much portion left with us. A step ahead, say when we will reaching at 4, then it will be again leading us to 3/4 portion will remain, and it will lead to 1 2 into 2 3 into 3 4. Sequentially we will reach at 4 5 5 6 6 7 and so on, n over n plus 1. See, we can have, and like that at the end we will reach at n over n plus 1, and we know it accepts reorganization as 1 plus 1 over n, and when n goes to infinity it leads to value 1 over 1, means the 1 only. Therefore, if we go on constructing the chain of subsets of the set D1 of duplexes, and if we reach at D2, D3, and continuously we going, say up till Dn, and n if even goes up till infinity, at the end still there will remain value 1. It is this reach at 1, even at infinity, is the requirement, and it is this requirement which will satisfy the conjecture. The conjecture is that every even number greater than 2 can be written as a sum of a pair of primes. It is this reach which is the expectation. It is this reach which is being reached at by this proof. This proof, as it is helping us how to have the reorganization for the range of value E as an even, accepting first a or construction as a pair of limbs, then having construction of the duplexes, and then having a ruling out for the composite duplexes, to have at least one split for every E as a sum of primes is the expectation, and it is the expectation which is being reached at. However, in this proof, as a caution, one restriction is put that we will only check as a general proof with E being 66 onwards or greater than or equal to 66. We are leaving it a elementary exercise of physical verification up till value 64, and this tabulation is a very blissful elementary exercise, and this tabulation is given here and it can be reached out. But the question again would be that the formats availed, the constructions reached at, are the constructions or the values or the features of the format of the creator's space, means for space. The proof is silently availing the values, features of the format of creator's space, a four space, which is a spatial order space. Being a spatial order space, 2 space is playing the role of a dimension. As here 2 space is playing the role of the dimension, as such the logic here is of a spatial order. It is not a logic of a linear order. By this we mean that the ultimate logic being availed is that if we are working with a sequence S1, S2, S3 and so on, then the gap between the pair of values of the sequence S1 and S2 as well need to be bridged. This bridging is there by having another sequence S11, S12, so on, so that we can reach from S1 to S2, and still further from these two members S11 and S2 as well, we have to reach at another sequence to bridge this gap, and this is going to go on infinitely, and it is this infinite reach which is going to be reached, like reach from 1 to 2, 2 to 3, 3 to 4, 5 and so on. And reach from 1 to 2 we know is equal to that we are having 1, and here we are having 1 into 2, and from reach from 2 to 3 is going to be a reach from 2 into 3 over 2. A step ahead, reach from 3 to 4 was going to be 3 into 4 over 3. So see, this reach requires 2, then 3 over 2, then 4 over 3 and so on. This reach is 2, 3 over 2, 4 over 3 takes to n plus 1 over n, which accepts an organization 1 plus 1 over n. And when n goes to infinity, it remains the value 1. Therefore, it is a 2 is having a reach at value 1. And in the reverse sequence, now 1 is equal to 2 into 1 over 2. And 2 is equal to 3 into 2 over 3. So this reverse sequence is 1 over 2, 2 over 3, 3 over 4 and so on, which is equal to n over n plus 1, which again takes us to 1 over 1 plus 1 over n. It takes to 1 over 1 is equal to 1. So it is this reach from 2 to 1 and from half to 1. Now this pair of units availability is there only because we are in a 4 space. In a 4 space, 2 space plays the role of a dimension, and within 2 space means within a surface we can simultaneously have interval as well as a square. This simultaneous availability of interval and a square within a square means we can work with a single axis and we can work with the pair of axes. Both are simultaneously available. Therefore, the single axis is having a double role as a single axis and as the first axis of the pair of axes. Therefore, it is this double role of the single axis. It is this double role of the single axis comes to be that value 1 as it is reaching us 1 cross 1. Now this is the reason why 1 is being not accepted as a prime. And further, when we are at the values 1, 2, 3, 4 along a line as a linear units, and then simultaneously we have 1 into 1, 1 into 2, 1 into 3, 1 into 4, and it takes us to a spatial units. So we are working 1 into 1, then 1 into 1, and then 1. So it is 1, it is 1, and it is 1. Up till here is a linear pair of units. It is here is a spatial pair of units. Now it is this reach, it is this format which is ultimately going to be the format of a creator's space, 4 space, and not of a 3 space, a linear space. So we have to shift from linear order to a spatial order, and the spatial order itself is having 5 space in the role of an origin, which is a solid order. And it is here where we can see that when we are having a x-axis, y-axis and z-axis, x-axis, y-axis and z-axis, then we can have 1, 2 and 3, and in the reverse orientation we can have 1, 2 and 1. So 1, 2 and 3. So 1 as 3 and 3 as a 1 is the availability. It is this availability, it is this feature which is being missed by the modern mathematics axioms insistence upon linear, while same takes us to solid order. So it is from dimension to domain. So one space as dimension as positive 1 and minus space 1 as its dimension. So shift from plus 1 to minus 1 is a shift from domain fold to a dimension fold. It is this shift which is missed, which goes unnoticed, and it is this missing of a reach from domain to dimension and dimension to domain, which is coming in the way of the modern mathematics, modern mind, modern axioms. From next session, we will take up step by step how there are being raised difficulties by those who insist the proof justification in terms of the linear axioms. We'll take up each and every response which I had during last number of years in writing from the mathematicians and scholars from different parts of the world. My proof as such was initially not considered as the prize which was offered. It was said it is only meant for Europeans and non-Europeans. I as Indian being not European, so my proof was not considered. However, the academicians and mathematicians have been good enough that they had exchanged large correspondence with me, and I have many responses, and I have considered all those responses, and I feel that those responses have logical difficulties only because of the insistence for the linear logic, while in fact it is to have a spatial logic. That means that when we want to reach from first value of a sequence to the next value of a sequence, there happens to be a jump, and this jump itself is also to be filled by the sequential steps. That is why that we have to have points setting along a line, and then each point is to become a line, and then the lines are to be again reached at, and it will take us to a spatial format. It is this spatial format which is the basis of the dimensional synthesis. Modern mathematics, modern mind, Mardian axioms as such are far away, many steps away from the concept and phenomenon of synthesis of the dimensions and dimensional frames. The modern mathematics is many miles away from conceptualization and applications of the nature's phenomenon of synthesis of dimensions and dimensional frames. That is why the modern mind, while considering the solid geometry, are not appreciating that within each of the 8 corner points of a cube is embedded a 3-dimensional frame of half dimensions. How a 3-dimensional frame of 3 dimensions splits into a pair of 3-dimensional frames of half dimensions, and the same is responsible for the structural setup of a cube as a set of 11 structural components. Thank you very much.